8.2 is called arithmetic sequences and partial sums, however you guys want to say it. I'm going to give you guys like little tidbits, little hints here and there, so go ahead and write them down. When you see arithmetic or arithmetic, however you guys want to say it, you want to think add and subtract, all right? When we talk about geometric, we're going to talk about multiplying, but an arithmetic sequence or series only deals with addition or subtraction, okay? We talk about common, the terms, like term 1, term 2, term 3. We use n as the term number, and there's something here, we're going to use the variable d, and it's called the common difference. That's what's happening to your equation every single time. Like if your pattern is plus 3 every time, that's the common difference. If it's minus 5 every time, it's a common difference. I will sometimes refer to this as slope. I told you guys last week that an arithmetic sequence is linear. Means it makes a what? Makes a line, okay? That's why we can refer to this as your common difference as slope, because if you were to graph the sequence, it would make a line. It's going to go up and over, up and over, up and over. It's a linear sequence. So when you look at these, all right, the sequence whose nth term, like the 20th term, the 50th term, whatever, we're writing a rule. Like if you're given this 4n plus 3, and you plug in 10 for n, you're finding the 10th term. So it'd be 4 times 10 plus 3. All right, so what we're going to do is we're going to be given a sequence, and we're going to have to write the rule. Now, there's a couple ways to do it. I'm going to give you a formula that will work every single time. But like I told you before, guys, if you notice here, from 7 to 11 to 15 to 19, what's happening every single time? Okay, so I go 7, 11, 15, 19, and so on. Do you guys agree with me? This is the first term, second term, third term, fourth term, right? I'm showing you why it's linear. The 0 term would be your y-intercept, all right? If we're talking about y-intercepts and all that stuff, y equals mx plus b. This would be our 0 term, and this is our slope or our common difference. So Maddie just told us what's happening every time. We're adding 4, right? So to write this rule, you could do this without the formula. You could say, okay, it's adding 4 each time. That means 4n, it's our slope. Then our 0 term. Well, if I'm adding 4 to get to the next term every time, how do I find the term before? You would subtract 4. So 7 minus 4 would give you 3. So your rule is 4n plus 3. Right? I'm going to give you a formula to do it, but that's just so you guys can kind of put that concept together. An arithmetic or arithmetic sequence is always going to be a line. You're adding or subtracting the same thing every time. Now in WebAssign, if you guys notice, look, here they have 7 minus 5n. For some reason, whatever it is, WebAssign either puts n first or puts n second. So if you get like negative 5n plus 7 as your rule, and you put it in and it doesn't work, just switch it, do 7 minus 5n and see if WebAssign will take it. I personally like it written like this because that's in slope-intercept form, and that's kind of what you guys are used to seeing. But I'm not going to mark it wrong if you have it written any other way. I'm just telling you WebAssign might see something a little differently. Everybody with me on that? You okay? Yeah. All right. So do you notice in this sequence, well, how'd you get from 2 to negative 3? Negative. That's why my common difference is negative 5. That's my slope. So if I was going to find the 0 term, the one before it, instead of minusing 5, we would do what? Add 5. Right? So 2 plus 5 is 7. That's where they got the 7 from. You guys all right with that? Okay. All right, moving along. Okay, here's the formula I told you that I'd give you. All right, this formula, you don't even have to think, really and truly. You don't even have to think. A sub 1, this is your first term. D is your common difference or slope, what you're adding or subtracting every time. And you can just plug it into this formula and figure out what the next term is going to be. If I have something like this, it says Find the formula for the nth term of the arithmetic sequence. It's important that they tell you what kind of a sequence it is, because what do you know you're going to do every single time to get to the next number? What does arithmetic mean? You're going to either add or subtract. That's telling you, oh, okay, I can use this formula. They tell you here that the common difference is what? Common difference is, so I would write D equals 3. This is how you would show your work. They tell you what the first term is, which is what? 2. So I'd say A sub 1 equals 2. And then I would just use the formula. So it's A sub n equals, what's that formula say? First term plus n minus 1 times the common difference, which is 3. Now, if we were simplifying this, guys, what would you do first? Distribute the 3. Good. So you have 2 plus 3n minus 1, correct? Minus 3. Hi, Monday. This is a 3. I'm thinking ahead. And then we combine like terms. So my rule is A sub n equals 3n minus 1. So if I said to you now, what is the 200th term in this sequence? What would you do? How would you find out what the 200th term was? Plug in 200 for n. But there's your rule. So if it's arithmetic, you can use this formula every single time. Questions? Yes, sir. Where? Right here? D. Because it's the common difference. I know, I hate when they start using different letters. My handwriting is so good. All right, here's a different kind of a problem. All right, we're just going to think through this a little bit. Let's write down what we know. All right, it says the fourth term of an arithmetic sequence is 20. So A sub 4 equals 20. Agreed? Okay, so then it says the 13th term, so A sub 13 is 65. Write the first several terms of this sequence. Did they give me the common difference? No. Did they give me the first term? No. I got the fourth one, but I don't have the first one. So there's a couple different ways you guys could do this. Some of you would be able to write down like this, like 1, 2, 3. The fourth term is 20. And then go 5, 6, 7, 8, 9, 10, and all the way out to 13, and then say 65 and figure it out. It's exactly what I was going to say. You guys are going to have enough time on your quiz to just, like if I ask you what's the 55th term, for you to just keep adding 3 till you get to the 55th term. All right, you're going to have to show your work. So in a case like this, all right, when you're given 2 terms, but not the stuff that you need, let's first figure out what our common difference would be. How far is it? How many spaces are between the 4th term and the 13th term? How many? 9 spaces. Good. There's 9 spaces. So would you guys agree with me that the common difference would have to be applied 9 times to get from here to here, right? Whatever the common difference is, you got to do it 9 times. So let's find out what that common difference is. To get to the 13th term, oh, bad color. To get to the 13th term, I'd have to do what? Take the 4th term and add what to it? 9. We're looking for the common difference here, but I like the way you're thinking. I have to find out what I would have to do 9 times. All right, so let's just figure this out. This works, guys, if you're given 2 terms that aren't what you need. You've got to have the first one. So you just put the one that's further away, right? I'm not going to say bigger, because if it was if it was going down each time, it'd be a smaller number. But the one that's further away from the first term, which would be 13. So just fill in what you know. I know that the 13th term is 65. I know that the 4th term is 20 plus 9 times D. Let's find the common difference first. Then we can figure out everything else.
So would we subtract them?
Yeah, we're just going to solve like we would a normal problem. Subtract 20 from both sides. So 45 equals 9 times D.
And
Divide by what? 9. So the common difference in this problem is 5. All right, so the question says, write the first several terms of the sequence. All right, it doesn't matter. 4, 5, whatever.
So then do we start from 20 and then count by 5?
You can. Yeah, you could absolutely do that. Madison said, should I start at 20 and just count by 5? Okay, well, let's figure out what the first few terms are. If 4 is 20 and it's going up by 5 every time, how would I go backwards? So what's the third term? What's the second term? What's the first term? 5, right? What's the rule? If I asked you to write the rule, a sub n, the rule for this is what? What's the common difference every single time? 5, n, right? And then what do I have to add or subtract? Anything? Why you say minus 4? I'm not saying that. I'm just wondering why you're saying minus 4. Because you started off with the fourth term? So are you thinking that? Okay. All right. That's a good thought. There's nothing wrong. I was just wondering. We're just talking. Think about this. This is the first term, right? If I plug in 1 for n, what's 5 times 1? 5. Is that the first term? All right. What about 2? Let's plug in 2. What's 5 times 2? 10. What's 5 times 3? 15. So what's the rule for this problem? Just 5n. Very good. A sub n equals 5n. Now, if you guys got a different problem, I promise you'll be able to figure it out. This is all about problem solving. You'll be okay. I promise. You'll be able to write the rule. Questions? We all right? Okay, let's look at the next one. Write the 54th term of the arithmetic sequence 2, 9, 16, 23. This is important because what does that word mean? It's going to happen every single time. Add or subtract. Okay, that's important. Now, there's 2 ways you can do this. I'm going to show you guys both ways. I personally like to do it like it's an equation for slope-intercept. That's just me. But you can do whatever you want. First thing you have to do, guys, is you got to find out what the rule is. All right, what's going on? Well, no, we'll go with the formula first. A sub n equals A1 plus n minus 1 times d, right? Do I know what the first term is?
No.
Yes. What's the first term? 2. You're fine. Don't apologize. What's the common difference? What's going on every single time from 2 to 9? What are we doing? Adding 7. Okay, so if I put this in my rule, my formula, I have 2 plus n minus 1 times 7. What do I do with 7? Distribute it. Good. So 2 plus 7n minus 7. So my rule is a sub n equals 7n minus 5. Okay? Be careful here, guys, that you don't make a silly mistake. Now, if you did make a silly mistake, say you said minus 9 because you just weren't paying attention, you can always check what term number is 23. It's the fourth. So when I plug in 4, what should I get out? 23. So what's 7 times 4? Minus 5. So the rule's right. So now the question that was asked was, what is the 54th term? So that means you would say 7 times 54 minus 5. What's 7 times 54? 378 minus 5. Yeah, but I mean, just think. 7 times 4 is 8. Carry the 2. Right? 7 times 5 is 35 plus 2 is 37. Okay. What's 378 minus 5? So the 54th term of this sequence is 370 what? 373. That's all you got to do. Or you could, this is how I do it just because I'm a weirdo. First term, second term, third term, fourth term. I like to do this. 9, 16. What's my slope? So I had 7n, and then what's my term before it? If I added 7 every time, how do I go backwards? Minus. So I get subtract 7, negative 7 and 2 is same thing. I don't know why. I just like doing it that way. I don't care either way you do it.
So you always have to put that like you can't just be 7 there.
Pablo just asked the question, how come it's just not 7n? So think about it. Like the third term, I want to be what? 16. What's 7 times 3? 21. So that's not the right rule, right? So you can always check. You can always go back and check. Questions, comments, concerns?
Wait, Miss Mary.
Yep.
Okay, wait. The chart kind of confuses me.
Then don't look at it.
But I want to learn it.
Okay.
So, like, is the n at the top row, like, to find n, I guess? So, like, would you do, like, 7 times 2 minus 5 to get 9?
Okay, so this is my chart, right? This is my x,
Yeah.
and this is my y. My input, my output. So would you agree with me that the 0 term would be your x-intercept?
Yes.
Okay, so that's where I'm getting that from. So if we were writing this in slope-intercept form, you get y equals mx plus b. Well, since we're talking about sequences, y is a sub n. M is your common difference, right? It's your slope. And instead of x, they're using the letter n. So it would be slope times n plus your 0 term. So if the first term is 2, second term is 9, 16, 23, right? So what did we do every time to get to the next term? That's our common difference, our slope, right? So it's 7n. Now if we're adding 7 to go up, to get the term before, you would subtract the opposite. So what's 2 minus 7? Negative 5. Same thing. I don't know why I like that better.
So it just takes longer though, right?
In my mind, it doesn't. But again, either way you want to do it, we can practice.
Well, then what's the shorter way? Like
You can either do it given the rule,
oh.
or the other way. It's about as short as it's going to get there, Pablito. All right, guys. Now we have this is so hard. Oh, I got Carlos's attention again. All right, when you're talking about the sum of a finite arithmetic, what does the word sum mean? Add. What does finite mean? It ends or limited. Okay, watch. This is easy. What is n? What have we been talking about? N stands for what? The term number, okay, or number of terms. We'll just say that. What is a sub 1? It's the first term. If this is a finite, what is a sub n? Finite means the sequence does what? It ends, so this is the last term. Right, now some of you are going to say, can I just add all the numbers up? Yeah, to check yourself. But you're going to wreck yourself if you don't write the formula and everything, so let's focus. I want to know the sum of this finite arithmetic sequence. Now, what can you guys do with all of these numbers? You can add them up. You can just go, add them up. Okay. But I have to see how you would get that. Right? Carlito? Here we go. Here is your formula. The sum of your finite arithmetic sequence, a sub 1 plus a sub n. This is what I need to see from you guys. N is the number of terms. How many terms are we talking about? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? A sub 1, what is my first term? 1. What is the last term? 19. Now we're going to plug this into our formula. So we have 10 divided by 2. Agreed? And then a sub 1 is 1 plus 19. This is what I need to see. I know you smarty pants can just add everything in your calculator and do that to check, but I need to see this work. 10 divided by 2 is 5. What's 1 plus 19? 20. So what is the sum of this finite arithmetic sequence? 100. Yeah, I'm sure. Do you think I'm going to give you a ton of those? Probably not. Probably not.
Miss Meadows,
Yes. What's up, buddy?
where did you get the 10 from?
The however many terms there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good question.
Oh, okay.
Yep.
Thank you.
All right. Here is the question, Carlos. We're almost done. Here is the question that you guys will likely see. Find the 150th partial sum of the arithmetic sequence. Okay. Think about what they just told you in this problem. All right. What did they tell you? They told you what the first term is, right? What's the first term? 5. Did they tell you what the last term is? No. They didn't tell us what the last term is. Do I know how many? It is finite. Do I know how many terms that I have to find? Okay, good. So I know how many, I know the number of terms. That's good. I don't know the last term, so I can't use my formula just yet. Any ideas?
Use the formula of remember that you do.
Okay, why? Because it's a lot of numbers. I like that. What is it? 5, 16, 27, 38, 49, ... All right. I like what Carlos is saying. We learned something at the beginning, right?
You're adding 11 each.
Okay, I'm adding 11 each time. So that's our common difference. D is 11. Now, some of you are going to say, well, can't I just add 11? Sure. Add 11 145 more times. That'll give you your last term. Then you can plug it into the formula.
Since you multiply by that number,
Mm-mm. Right. Can I write the rule? My rule would be the first term, which is 5, plus n minus 1 times what? 11. So distribute. 5 plus 11n minus 11, right? Agreed? Okay, so my rule is a sub n equals 11n what? Minus 6. Okay, now did that help us completely? Are we done? No, I'm trying to find what this last term is. I plug in, what do I plug in? 150, okay, good. So I say 11 times 150 minus 6. What's 11 times 150?
1650.
1650? Minus 6 gives me what?
1644.
So now I know that this last term is 1644. So now I can find the sum. The sum would be n over 2 times what? A sub 1, which is, well, I'll put that in a second. So I did 150 terms, right, divided by 2. 5 plus 1644. Okay. What's 150 divided by 2? Mm-hmm. What's 5 plus 164? 1644. 1649. So the sum of the first 150 terms is what? Perfect. Good. Now, again, you could have just added 11 145 more times and then added them all together.
can you do like 11 times 145 and just add it from 1 and then you get 1644? But you have to say 40.
I want to see the formula. That's a good way to check. Pablo just said the same thing. That's a good way to check, but I want to see the formula. It's good that you guys saw that. So look, in this case, the first thing we did was we found the rule, right? We found the rule. Then we plugged in the given term number that we were looking for. Whoops. Right? Then we summed. I don't even think that's a word. Then we found the sum. We plugged in, because in order to find the sum of the finite, you need to know how many terms you're talking about. You need to know the first term and the last term. So we got to find the last term. Everybody with me? All right, so now you have a WebAssign, 8.2 WebAssign, that is due Wednesday morning. All right, all this is, guys, is just plugging stuff into formulas and just kind of using your brain just a little bit. Geometric is a touch harder, but not much, I promise. Summed.